All right, we are on 3.8, domain and range of quadratics. You can see number 2 is slightly different from number 1. We can do this a variety of ways, one of which is to use Desmos, our graphing calculator tool online, and enter in the equation just as we see it. So we have negative x squared minus 2x plus 8. So that's, you can pull up this keyboard at the bottom and type in negative, let's see if you can see the whole thing at once would be nice. Okay, so negative x squared minus 2x, you can kind of see it taking shape over here, plus 8. And I'm going to zoom in on the graph. And some key points that will help me to transfer this to my paper would be the vertex, which if I tap on that, it gives it to me. It's negative 1, 9. So I'll graph that. Negative 1, 9. Followed by, we can kind of use that same strategy as in the previous problem, over 1, down 1, left 1, down 1, over 2, down 4, left 2, down 4, parabola. So we'll count it off. So over 1, down 1, left 1, down 1, over 2, down 4, 1, 2, 3, 4, left 2, down 4, parabola. Now the question is going to ask me for intercepts. So it might be helpful to just go ahead and include those. These are fairly obvious, negative 4 and 2. So we'll put negative 4 and 2. Back up a little bit here. Domain, all real numbers. Range, we have a maximum and it's at 9. So that means that our y values will be less than or equal to 9. The vertex, as we saw earlier, is at, again, it's so nice on this tool, you can just tap on it and it will appear. Any point really works that way. So negative 1, 9 for the vertex. Is it a maximum or minimum? If it opens down, if we have a negative in front of the x squared, it opens down. So it is a maximum. X-intercepts, negative 4 and 2. Axis of symmetry, remember go back to the vertex and it's the x value, so x equals negative 1. Right, and that's this line that divides the parabola in half. Number 3 you can do on your own. And then down here at the bottom, the quick tips. If y equals ax squared plus bx plus c, and a is less than 0, so it's negative, then the graph will open down. That's what we saw in both of these. And it will have a maximum. Given y equals ax squared plus bx plus c and a is greater than 0, then the graph will open up. When it opens up, it has a minimum. It'll have a lowest point. I'll go ahead and do one more on this page. Similar types of questions. Find the vertex of each parabola, graph the function, and find the requested information. So I'm going to go ahead and graph here. I can erase my previous equation simply by tapping on that. Get a better angle. and type in y equals x, so it's x squared, minus 2x, minus 2, you can kind of see it taking shape over here, minus 2x minus 3. So you can see my graph. I kind of took for granted I have a touch screen, so it's nice I can just adjust it using my fingers, but you could also adjust using the tool menu over here. You tap the tool menu and it gives you the option of the domain, the x values. So our graphs on our paper go from -10 to 10. So I could literally enter in negative 10 to 10 and make the step 1. So now you can see the x-axis is labeled, it's going up by 1s, and then I could do the same thing with the y-axis, -10 to 10, step 1. And now you see those all labeled in. Now, I also can unselect the minor grid lines. So that kind of makes it a little bit more clear, since I only have grid lines where there are actual values. So with this information, let's get a key point, let's get a vertex. That's at 1, -4. Vertex is at 1, -4. So let's plot that. 1, -4. I can use my little song, go over 1, up 1, left 1, up 1. I went over too many. Left 1, up 1, over 2, up 4, left 2, up 4, parabola. Max or min, it's got a min, right? It's a lowest point, so that's a minimum. Direction of opening, up. State the x-intercepts. That worked out well. That's -1 and 3. State the y-intercept. This one asks that question. That's not a question. The previous problems asks, so it hits the y-axis there at -3. Sometimes it's obvious, and sometimes it helps to take a look, tap it on the screen or on your computer, and it pops up with a point. Domain, it's a parabola, so all real numbers. Range, look at our minimum value for y, so it's going to be y is greater than or equal to 4. The axis of symmetry here is going right through 1. Again, that's the x value of the vertex, so x equals 1 is your axis of symmetry. We could identify A, B, and C. These values really are useful if we were solving using the equation for calculating the x value of the vertex, plugging it in, finding the y value, versus using our Desmos tool. So you can kind of ignore these. I will say on number 6, the little song doesn't work because we have a 2 as our value, -2 actually. So look for some key points rather than using the song. Number 7, it says find the domain and range of each. It doesn't have graphs, which is interesting. These are new problems. So to find the domain, it is a parabola. I know this because it has an x squared as the highest degree, and so my domain is all real numbers, or all real numbers. The range, well, let's go ahead and graph it. 2x squared plus 9x minus 3. 2x squared minus, or sorry, plus 9x minus 3. Come over here, look at the graph, and the range, so I have to find my vertex, and here it is. So this is super helpful because eyeballing this, I couldn't have gotten an exact value, but because I can click on the vertex, it gives me an exact value for my y of my vertex, so negative 13.125. Negative 13.125. Now, I have to decide greater than or equal to or less than or equal to. Since this is a minimum, it's going to be greater than or equal to. Number 9 is a little different. It's already graphed for us. So if we want to state the domain and range, we just have to look at the graph that's already made for us. So again, looking at this y value, although, again, that is not exact. So you can't look at that and know the exact y value there. So it is at an x value of 1/2. So you could plug 1/2 into here and figure out what the y value would be, or you could graph this in Desmos and then do what we just did on the previous problem. Same thing here, although this is an exact value, so we can quickly find the range there. Similar types of questions here. State the domain and range, just more practice. On the back, it's a little bit different. We want to describe the transformations. So I want to know what happens between when y equals x squared and y equals x plus 8 squared. So I'm actually going to graph both of these on my Desmos. Y equals x squared. Here we are. And then you press enter and you have an option to make another equation. We can make it right on there. So it's y equals, and I think we've had conversations, the y equals part not necessary, but it doesn't change anything, so I decided to include it this time. X plus 8 squared. Can't find it. Where is it? Ah, there it is. Okay. So the question is, what happened? What is the transformation from this first graph to this second graph? And it's fairly easy to describe. We can just say this graph shifted 8 units to the left. So we can say shifted, or shift of 8 units left. So we could say that as shifted. The technical term for that would be translated. Number 15, it's very similar. So you're going to go back, you're going to enter these both in, and then you're going to have make a statement about the shift that happened between here and here. Okay, that happens in each of these. I'm going to do one more question for you. So we have number 17 is asking for from y equals x squared to y equals x minus 5 squared plus 1. So that first equation would be the same. And I need to change the second equation to, let's see here, -5, and then +1. All right, what happened here? Well, we did, remember purple was our first, and then the black one was the second, so we went shift of 5 units to the right and 1 unit up. Nope, wrong spot. Now we could look at these and know, we've talked about vertex form of a parabola. The vertex of this parabola is at 5, 1. And the vertex of this is our parent function, is at 0, 0. So without using Desmos, I could realize that going from 0, 0, the origin, to the point 5, 1, I went 5 units to the right and 1 unit up. Same thing here. I could notice that we have parent function 0, 0 for the vertex to -8, again, opposite of what's ever in the parentheses, and then +0, there's nothing out here. So from 0, 0 to -8, 0, we're moving 8 units to the left. Same position on the y-axis. So you can choose whichever method you'd like to do. And then, fun little question here, number 20, you get to create your own transformation question and then give the answer. And that's it.